Everyone to simulated engineering on Roblox. So we'll be starting with Mac explaining the real life engineering stuff that we've want to explore through Roblox a bit. So you want to get started? Let's open up Roblox Studio. Give me a second. Hi, so this is a Roblox Studio environment I just built using free models. This is wait one second.
Just loading up.
Yeah. Okay. So don't worry about it. I have it up on screen. There we go. So you want to get started with the airplane?
Yeah, if the stream's all visible and okay,
Yeah.
I
Can
can
you all
get
see my
started.
Roblox Studio environment if someone can respond in English? Uh, Hi, can everyone see my Roblox environment? If you can respond in English, please. Hi, Roblox. Yeah, can anyone just please confirm real quick? I'm not able to receive a confirmation about it, please.
Uh,
Okay, I'll just assume they can see it. I think they can. That's fine.
yeah, okay. Do we get started now then?
Yeah, we'll just get started with the plane.
Okay.
I think
So
there's a
hello
stream
everyone.
delay. Yeah. Okay. So this is Mechatricon. Real quick before we get started. This is Mechatricon. He's a engineer, as I mentioned earlier. He's a prospective engineer, and he's published some research papers in various research journals. So he's got quite a quite a good hand with engineering. All right. Awesome. Thank you so much, everyone. Uh, okay, let's get started, everyone. Okay. So
Yeah,
I'll hop
okay.
in my
So
environment. Yeah, you can start explaining.
yeah, I think it's there now, so we'll get started. First, we already mentioned, we're gonna start with airplanes. So first, I guess you can get started and start flying the plane. And while you're navigating, I'll start about with the explanations.
All right, great. I'll
So
try to get in the airplane here.
okay.
It's not okay. Wait one second. Yeah, I'm in the plane. Okay. So you can start
So
explaining, and then we'll get back to it. Yeah.
So first we'll cover the main engineering principles behind how all of this works, and then how Roblox sort of helps in understanding how all these machines work, and then we're gonna go over the code and how you can sort of create it on your own. Okay, so we'll get started with the plane. If you'll just get started and fly it.
Yeah, I'm taking.
So,
Yeah,
okay.
I'm an amazing pilot. I didn't really put a lot of thought into this studio environment, so we'll just quickly take it off. Okay, we're in the air. Here we go.
Okay. Great. So first, I'll basically talk about the engine. That's what sort of lets the plane itself fly. Now, the engine in this plane, because it's sort of a commercial plane that you'd see, has a propeller engine. So there's two types. One's a jet and one's a propeller. Propellers are usually low power and they're for heavyweight aircrafts. They're what you'd see in the flights you normally go in. On the other hand, jet engines are more powerful, so they're more like for traveling at supersonic speeds and more often in military aircrafts. And talking about this aircraft, this is, well, an airplane, unlike a helicopter. So, what the main difference is, the wing is fixed, so the wings don't move. Now, the plane essentially moves in three ways, which we'll also show it to you. The first is when you move up and down, or say when you're elevating, you're taking off, and then when you're landing. So the up and down movement is controlled by something known as the elevator. If you'll look at the back of the plane, you'll see there's two sort of rectangles, and what they're basically trying to do is they're flaps that move up and down, and basically, what happens is when you move it down, your plane essentially goes up and vice versa. This lets you change your height and lets your plane go up in the air. Then the second one is basic turning, like what happens in a normal day to day car. That's when your plane moves directly left or right, that we're showing here in the stream if you can see it. And now that's controlled by another surface. If you'll see, there's sort of a fin at the back of the airplane. That's what controls the left and right. So this itself has its own sort of rectangle fin that moves left and right. This is somewhat like how fishes or aquatic creatures move. If you'll ever see a shark or something, it moves its fin back and forth, and that's what lets it move right and left. So that's what works in a planer similarly. Then the most important is when you're turning the plane, right, we're showing in the game, it sort of rolls towards the right or it rolls towards the left. Now this rolling is the most important type of turn. So it lets you move the plane backwards 180 degrees or perform maneuvers. This is controlled by the wings you see. I'll come to them in a bit. But the wings basically, they have these flaps, and when one moves up, the other moves down, and that's how the plane sort of rolls its way like a barrel. And these three combined let the plane fly and go wherever and wherever they want. One thing I mentioned earlier that the engine is what lets the plane fly. Well, that's not the main important thing. The most important is the wings that you see, the two wings on the side. That's what lets every single plane, helicopter, or anything really fly, even birds. So the shape of the shape of these wings is what's really interesting because if we can have a zoom in on the wings, that would be great. If you zoom in on the wings, you'll notice it's a bit curved. Shape is a bit it's pointy at one end and a bit thick at the other. What this does, the air from the front sort of pushes its way back. Then the wings are shaped so that air takes more time to fly from the top than it does at the bottom. So there's sort of this physics involved known as Bernoulli's principle, wherein because speed and pressure they're inversely proportional. Now the pressure below the plane where our character is standing is greater. Now what happens when there's too much pressure that's pushing on something? It expands. So this pressure is sort of what pushes the plane upwards. It's sort of like filling a balloon completely and then you let it go. So the balloon sort of travels. That again shows you how the pressure flows. Now that's called the Bernoulli's principle, and that's between the relation between speed and pressure. One more thing, if we'll go under the plane, you'll see the wheels that let it fly. Now, there's again a very interesting study behind these itself. Because when your plane's taking off or moving, it's sort of rolling and it requires the wheels. But then when it's in the air, it causes something known as drag, which is bad. It reduces the
Can you
extent
pause
to
for a
which the
sec?
plane flies.
So
Yeah.
we have a question real quick. How does the engine work? If you can re-explain.
Okay. Okay, I'll address that. So I'll talk about the propeller engine in this case because that's the most common one, really, and that's the really
So
fundamental
we'll
thing
show
here.
you a propeller engine on screen real quick.
Yeah. So I think you can go to the front. That's a better view.
Yeah, I'll quickly go there.
So what a propeller engine does is it basically pushes air. Now that may sound a bit weird or confusing, but you can picture it. Yeah, we have a close up on it. So it has blades and they spin like a fan. They spin very, very, very fast. And what this spinning motion does, it sucks in the air inside and then it increases the speed of the air and then it increases the pressure because the air is compressed. And when it's compressed, the pressure causes the plane to sort of push it all the way back. Now, this is what lets the plane move forward because, again, you're sucking air and you're pushing it back. If any of you are swimmers, you'd also notice that the basic principle of swimming, at least for your hands, is you push the water behind you. And when you push the water, you're pulling yourself forward. Again, because if you push something, there's an inverse force that applies on you. So that's what works with propellers. And that's what we've shown over here. And these are most common for sort of small planes like business jets. Then the engine that we had previously, if you could just show that, that's
What you
a
want me to shortly
fusion.
repeat?
The previous engine we had.
All right, sure. One sec.
So this is just a propeller. It's just a blade, and the wings are again shaped the same way as a normal plane wing. Now the engine that the plane we were flying on had, it's a fusion. Now most engines are a fusion because they one suck in the air and push it back, but then you increase the power with which it's pushed back. The jet engine, it basically increases that speed.
Right. Interesting.
And if you look there, yeah, you'll also
Where
see
do you want me
there's
to look?
many more
Oh,
blades.
this
Yeah,
thing?
this is fine. Yeah.
Yeah.
So
Okay.
you'll also notice there's many more blades here. So it actually sucks in more air. And if you'll go to the back, I want to show the back of the engine. Uh, okay. So the back of this engine is smaller in size, and what that does is again, it makes the pressure a higher. A higher pressure means it's pushed back more. And that pushing motion, what it does, it throws the air on the same wing because it's mounted on the wing. And now this air that's thrown, that's what lets the plane fly, that's what gives it lift, and it pushes it forward and upwards. So a plane sort of works by the air pushing it rather than it moving for itself, like how it works in cars. And that's how the engine works. I hope I answered your question. I'll go back to the tires if you can just show a close up
Uh,
of that.
you want the gears? Yeah. Okay. Sure.
The wheels.
The gears.
So
Yeah.
the wheels now, they're basically a necessity for an airplane because, well, it needs to catch up speed. And when it catches up that speed, it's in the air. But then it is not a good thing because the wheels cause something known as drag, and we don't like drag. We don't like drag at all. What we need to do is reduce the drag force because drag just causes the plane to lose out on its power. So it needs more power to
So,
travel.
Mac, we got
And
another
that's,
question. We
yeah.
got a question. Why does a plane get turbulence?
Okay. So turbulence can happen because of a variety of reasons, like a multitude of reasons. The most common is, well, bad weather. And what bad weather does is it interferes with the environment. So if there's thunderstorms and there's rain, the flow of air that we're again sucking and pushing and the plane is traveling with, that's interfered. Now the rain that falls creates more drag, and then you need more power to travel through. But at the same time, because rain is not even on all sides and it's sort of pushing the plane down, because again water has weight, and while it's pushing the plane down, there's sort of a turbulence because the plane's trying to come up and the rain and the weather is trying to pull it down. Then there's also one again very common phenomena where you're traveling up in the clouds and then there's risk of thunderstorms or it's very cloudy. So in that case, the plane becomes it sort of has to go through an obstacle course because again you need to avoid the thunder, you need to avoid the clouds, and when you're trying to do the obstacle course, the plane has to make some harsh turns, some harsh movements, and the movements itself, that's also what causes turbulence, because turbulence is basically any jolt that you face in flying, and that's the most common one. But another one that's sort of rare is either if something comes inside the engine or if there's a very cold weather. Now, the motors in the plane move and that does create heat, but when you're in somewhere like the North Pole or the South Pole, it is cold and ice can form. And then this again makes it harder for the engine to move. Again, turbulence. The other thing, and this is the worst case scenario, it happens very rarely, but it does happen in some cases, is if something comes inside the engine or
Could
something
you
comes
confirm it?
inside the propeller. Now, you can think of it, say, as any mixing machine or a blender. If there's something hard in it that stops the blender from moving, or something that disrupts it or slows it down, that causes the blender to work well less efficiently, and this is what causes the drag. So, and turbulence. So, there's a wide range of reasons, and these are the main ones. So, I hope I clarified your question.
Okay,
Um,
I do
yeah.
have one more. I have a question. What? Okay,
Okay,
so you
sure.
said like board strikes, and this is really bad because it like blocks the engine sort of, right? Okay, so uh what it makes what it does is kind of like you said that it blocks. So like what exactly does it do inside the engine? I didn't get that part. Just to clarify.
Okay. Um, the engine is basically a mixture of rotating blades. It's a mixture of hot air being pushed back, and then it's a mixture of sort of funnels or filters that again heat up the air and then they push it back. Now, the any bird or any flying object, that's obviously an obstacle, and it can cause damage to any of these. So there's a filter, right? Now, there's a chance that the obstacle can get stuck in the filter, so nothing can pass through. And if that happens, the engine is rendered somewhat useless. And that's again a very bad scenario, rarely happens. But in this case, usually, the recommended course is to shut the engine off, because you can think of it as sort of an internal car crash. Now, when cars have a crash or some crash happens, you need to stop the engine, right? Now, that's the procedure that you have to follow. So the plane just glides like a glider without the engine. And that is, again, a very bad case. But you need to do it because when the bird comes in, it has no way to exit it. And when it doesn't exit, it's stuck inside. So yeah, it's you can also think of it as puncturing your car tire. I think that analogy works better to explain what I'm
That
trying to
makes
say.
sense. Yeah.
But yeah.
Okay. Do you have more
And yeah.
content to cover?
No, this was about the airplane. Now I think we can move on to I'll show you the difference between what the helicopter does. You can
Okay, sure.
just go to the helicopter.
Do you want me to hop in the helicopter? Let's see if
Sure.
this model works. This is just a free model, by the way. So, okay, I guess we have a working helicopter in here.
Okay. Now a helicopter is slightly more complicated, I'd say. And by complicated, I mean it's more delicate. Now, while for planes you have these two very big wings, and there's more wings on the back, there's stabilizers and all of that. Helicopter has only one thing that truly gets it moving. Those are the chopper blades that you see on the top. And these blades, again, they push the air, they push the air down, and while it's being pushed down, the helicopter is up in the air. So again, the same principle here. But now, what you do to make this helicopter move is you change the speed with which the blades move. And if you can zoom in on the blades, you'll see that the center part, which lets it move, that
Right.
is like a joystick. So
Right.
it's
Yeah,
like a
that makes
controller
sense. Yeah.
joystick, yeah.
Yeah. Yeah. Yeah. Yeah.
And you can sort of move it forwards and backwards. So, like when we're moving down, you'll notice the blades sort of come forwards, and that's what pulls the blade down.
Ooh, that's kind of cute. That's actually kind of cool. If I'd say.
You're right. So,
Yeah.
the blades, they basically move in all four directions wherever you want to go.
Yeah.
Now,
That's cool. That's awesome.
right. Now, you may also notice there's also a spinning blade at the back, if you'll see.
Yeah. Yeah. Yeah, we see it.
Now, this is sort of a safety mechanism. Doesn't it doesn't really help that much in flight, but essentially, because the blades are moving in one way, helicopter would also move in the other way because there's something known as torque. A torque is just rotational motion. Say, like when you're spinning a fan, and the fan, it also spins the air around. Now, if we didn't have this blade at the back, helicopter itself would spin the opposite motion. And what this blade at the back does, it opposes the motion and it opposes the rotational force. So your helicopter can actually stay stable. And that's really why a helicopter, I'd say, is the most delicate piece of aircrafts that you could have, because everything has a very specific role and everything is for security and safety. So you need the wings at the back to be moving at a certain speed, the front to be moving at a certain speed, and so on. Now, how this is actually controlled is through the cockpit. Now, in for the purposes of Roblox, this isn't really important or significant because you don't need them and you don't use them when you're flying on Roblox.
Oh,
But
sorry, I
I'll tell
kind
you
of
about it.
left the helicopter mid. Yeah, I'm sorry about
Okay,
that.
yeah, no problem.
Okay,
What
another
would
thing.
happen?
What if an
Yeah,
animal and object? Oh, okay, that's a very cool question. Thanks for that, Kelly.
it is cool, but it is also very dangerous.
Now, for the
Because
animal,
when
obviously, what would happen to the helicopter though?
oh, it's dangerous for the helicopter if anyone's in it, and definitely the animal.
Yeah,
So
no,
first
he's
off,
asking like what would happen like engineering or physics wise.
yeah, in an engineering perspective, the animal or object would basically be there, and it would either need to be weak enough for there to be minimal effect, or well, if it's an animal or an object, it is going to be rigid, it's going to be hard, and then it's going to restrict the flow. Now, if the aircraft's moving, and if it hits the back rotating wings that you see, if that gets hit, that stops working. Now, when that stops working, your helicopter is sort of going to move round and round and round and round, and that is again catastrophic because if it moves at that speed, if you're inside the helicopter, you're again spinning at that speed, which is again deadly, and the helicopter itself will crash because there's no stabilization. Now, if it hits the top or the main blades that let it fly, again, it would get pushed into the main motor area. If you can see the helicopter, we can have it from the top view. The blades push the air down, which means it pushing it down. So an object would get pushed down to the engine part or the main part that rotates left, right, like a joystick. And when it gets inside that, again, the rotating part is damaged. If that happens, obviously the people inside, very deadly. But the helicopter itself, most of it has to be fixed or replaced. And that again could cost millions of dollars. And that's also a very interesting thing. Thank you for asking the question. Because when helicopters are being stored, and there's certain types of helicopters where the bottom part, if they have wheels, animals and say rats, they can get inside the aircraft through that gap. So what people do when they store helicopters is they create an enclosure around its leg so no foreign animal or object can get in, because if it gets in, its internal components are at risk. And because aviation is a very delicate piece of engineering, you need to avoid all of that at any cost.
That makes sense. Yeah,
And
that's
yeah,
very informative. Yeah. Do you want me to cover the Roblox part of the plane at least? The helicopter we'll leave for now just
yeah,
because of its
we can
complexity.
move on to
Yeah.
yeah.
So we'll quickly just like gloss over how we can, let's say, like if you had to. Okay, we have a question though. What would happen if the spinning blades are bent at the ends? Okay, you can go for that first.
Spinning blades are bent at the ends. What do you exactly mean by this? So, do you mean like if it's bent downwards or
Okay,
something?
so would it affect the flying motion as well as another question?
Okay. One interesting thing, not sure if it answers your question. I'll try to, based on what I understood. So, the blades are very, very, very big for a helicopter, and they're also very, very, very heavy. Now, earlier on, they used to make these blades out of metal. Now they make it obviously out of lighter composites, which are lighter. But what always happens? Interesting
The
thing,
blades are
not sure if
resting
or a
sorry about
helicopter
that.
is resting.
Yeah, sorry. You can continue. Yeah, sorry. Just anyway, continue,
Sorry?
please. Yeah, I
Okay.
just played the live stream by mistake. Yeah.
Okay. So what happens is the blades are drooping already. Whenever the blades aren't moving, it's drooping because it's again so heavy that it has to bend. Now, this happens because there's the hinge at the motor. That's the only thing that's holding the blade. And because the blades aren't moving, it bends or droops down. So yeah, the blades are always bent because of the weight. But what happens is when it flies so fast, that bending is avoided. Because when it's moved, the blades are again pushing in a circular motion, creating this centrifugal force, and the spinning keeps the blade straight. So, yeah, the blades are bent in the beginning, but the rotation itself sort of causes it to straighten because of the force that's acting on it. And yeah, I think that answers your question. So you can start with the
So
code
I'd like
part
to
of it.
inform us we have over 100 people watching us live right now. So thank you everyone for the support. Uh,
Yeah.
okay, so we'll get to the Roblox part of it since this is also a Roblox theater event. So I'm Bestinhop23. I am the lead programmer and head of content strategy over at Drift Paradise. I'm also currently working on two undisclosed projects and another one called Pacific Minigames. You'll see that one soon. Anyway, so I used to be working in this community we called Row Aviation, if you all have heard of it. So the Row Aviation community was basically something where there's this bunch of Roblox airlines and they host flights where you actually go on a simulated flight in Roblox. I thought that was really cool. One of the biggest airlines I used to work with, this one, it was called Aqua Airways, if you want to check it out. They host like flights and all that on just fully digitally. That's actually like if you just enjoy flying and want a semi-realistic experience of flying, they have virtual planes just like these, a whole fleet of it, and that's pretty interesting. Just if you want to go check that. Anyway, so about how you make a plane on Roblox yourself. So while I won't go into too much detail concerning this, just a overview event. I'll be hosting a event called Introduction and to Advanced Scripting on Roblox. So we'll go get into server client infra and all that stuff. We also have other event organizers who you know go ahead and talk about the stuff about like programming on Roblox. So that's if you want to get check that out. Anyway, so about how you build a plane. So you all notice when we hop in this free model airplane, or whenever you search for an airplane on the toolbox, I'd say, even though I don't recommend generally getting free models, for the purposes of this one, I did use free models. One sec, I'm just too fast in my walk speed. Give me a second. Okay, I guess the plane. I guess I'm not able to get in the plane, so I'll have to drop myself over there. One second. Yeah. So, hey, by the way, this is a very cool party trick. If you want to check this out on Roblox, you can just like move your character, I guess. Uh, with that, and yeah, that's just how easy it is. I guess I'm still not able to get in, so I'll have to like push myself a bit down. Yeah. So, if I were to like, let's say, hop in the pilot seat over here. Yeah, so if I were to hop in the pilot seat, as you all can see over here, when I click the plane tool, which allows me to, generally what happens is the plane welds entirely to my character. So what it does essentially is, if you have a bit of understanding of programming in Roblox, you understand that it loops through all the parts in the plane and welds them to the humanoid root part of my character. So over here, as you can see, humanoid root part. One second, give me a sec. So this is called the humanoid root part over here. So this thing basically allows me to like, you know, uh, pretty much control the plane as if it were my character. So what I can do theoretically is whenever I move the humanoid root part, which is the primary part of my character, it would move the entire plane. So essentially what I'm doing over here is adding body velocity or something like that. So like, you know how you fly on Roblox where you have like a fly command? It's essentially doing that, but by welding the entire aircraft to it. So we're using engineering principles on a character. This is most of the free plane kits Roblox do this. So basically all the engineering principles we explained for the airplane, we're just doing that on a character. So that allows us to, I think, relatively simplistically explore this, if that makes sense. Do you all have any questions? Please feel free to ask them. Uh, yeah, so that's essentially what it does. We will be exploring maybe like similar stuff on a more basic level in some other events, if you're all interested. And yeah, so you want to move on to another one, Mac?
Yeah, sure.
Okay, let's move on to the other system. For the other systems, for the hydraulic press at least, I will be exploring the how you can code it, rather, if you want. Anyway, Mac, what do you want to do? Do you want to do the hydraulic press next?
Yeah, we can go with hydraulic
Let's
press.
do the hydraulic press then.
You
Please
can
feel
just
free to
go to
drop
it.
questions in the chat. We're open to answer. If you drop a question, it's your first priority to answer it. We also have a Q&A session towards the end if you just want to ask us about any general topic like that. Anyway, yeah, please, Mac, continue.
Okay. So hydraulic presses basically they use less power to exert more power. They do is they let you squish things, for the lack of better terminology, and make it easier to uh, use power, I'd say. So it's basically hydraulic comes from water and pipe, and what we've made here is a simulated version of it, I'd say. But essentially, the original ideology of how it works is based on water and pressure. So, a hydraulic hydraulic press has two main parts, or I'd say cylinders,
Okay,
and
we
you
have a
can sort of
question,
see it.
buddy. We have a question. So I'll have to answer it. How do you
Yeah.
use Roblox to mimic the stuff? So again, we just glossed over this. Essentially, what we're doing is welding all the parts of the plane. So you have a model or you build it yourself. You build like the plane body and all that stuff. We just weld it to the character, and we rather like tween or like animate the character to move the plane. Obviously, we can't go into that much detail by the limitations of this event, but essentially, what you're doing is using principles of welding for that. If you don't know what a weld is basically what allows you to like stick two things together without actually, making them a union. That's essentially what a weld is like. And there's something called motors which allow you to change the dimensions of that weld. So essentially, what how we could have like tweened this thing over here is essentially what we could have done is put a motor over here as you can in this thing, and put a motor that welded this thing to the entire thing and made an angle so that it angularly tweens towards this. So it changes its angle so it can go down over here. It's a long story. You have to use a couple plugins to do this. So we'll have to explore this in another event. But essentially, what it does is you're animating the character to mimic your engineering, essentially for the play. Does that answer your question? If you have anything, please feel free to ask. Anyway, Mac, you can move on.
Okay. So you can picture it this way. There's two pipes. I mean, you can picture it from the one we've created here as well. And what how it works is one pipe is big and the other is small. And they both have any fluid or some water inside them. The small one works somewhat like a plunger, the one used in toilets. The other one is what I call the ram. And essentially, the plunger causes the ram to move. By that I mean, you take the smaller cylinder with the smaller liquid, you apply, say, X force, but the flow is again connected to the bigger cylinder, and the bigger cylinder exerts, say, 10 to 100 times that amount of force. So, what hydraulic presses do, they help you save energy and exert more force by compressing or pushing liquids.
So are you
Now
saying it?
water,
Question: Are you saying it uses the force of gravity to go down, or how does it like conserve energy? Because
not really gravity. Okay. So picture a syringe. What a
right.
syringe does, it pushes liquid or anything through its nib,
Okay,
right?
so it's using pressure, like the principle of
Hmm.
pressure is what you're saying.
Right.
Okay, right. Can you
So
explain this to
now,
for our audience?
yeah. So now I have a syringe. I connect it to a bigger syringe, and at the end of the bigger syringe, there's sort of a handle that can move forward and backward, or a piston like you have in Minecraft. So take this small syringe, and it's relatively easy to move the fluid or whatever you have outwards, right?
Yeah, I guess.
By moving that syringe, connected to the bigger one now. And because fluid or water can't be compressed, it needs to go out of somewhere. And then it goes out of the bigger end. But when it goes out the bigger end, because it's bigger, the pressure acts on a larger area. Because again, pressure is related to force and area. You add the area up, and the pressure also changes. The bigger area of the hydraulic press or the second syringe that causes sort of your piston to move and put more force while you're at it. And that's how it works basically in layman terms. So it lets you use a small amount of force to create a larger amount of force. That's how you sort of compress cars in waste bins. Is that's the thing. So all the waste cars, once say they've expired their life cycle, now to reduce the amount of waste you have, they're compressed. And how this is done is through hydraulic press. Otherwise, you would need the weight of about three elephants stacked on top of each other to compress and squish cars or any other devices of that sort. Because again, it's made to be rigid. So, hydraulic presses, they let us save time and energy by doing this. Now, today, we don't necessarily need mechanical parts like I've told about fluids. So, what happens now is there's all these circuits. So, at the push of a single button, you send out a current to allow the compressor to work. And that's what we've tried to show in this model that we've made.
Okay. Do
And
you want me to
yeah, you
explore it?
can explain more.
Okay, so this is
Yeah,
one of my
you can
favorite
explore it.
parts of the event. Do you okay? Explosion in three, two, one. Okay. So what it does is pushes and boom, explode. That's so cool. So what we okay? Do you want to finish talking and then I'll cover it how we do it in Roblox?
Yeah, okay. So what we just showed you an explosion. That's sort of to show you how anything works in a hydraulic system. Now, obviously, it's not for the sole purpose of exploding stuff. Obviously, that's not what we're trying to do. But say if you have a big metal object, it compresses it. And when it's compressing it, there's sort of heat generated, and the heat, that's what we've tried to show through the explosion. Now, because it's heating up and it's being compressed, there can be possible sparks and all. So that's what we've tried to show. It uses less force, and in this case, it's just touching a button or turning the lever. And with the turn of one lever, this whole hydraulic press is crushed. Now, the most interesting thing about this, I'll just tell you how significant it is. With the force it takes you to press a key or type a message in the chat, you can crush an entire vehicle, or you can crush about a block of pure metal, pure tungsten, or pure gold. Now, if you know anything about these metals, it is they are very hard. And if they're very hard, you need a lot of force to crush them. But that's sort of the beauty of hydraulic press. While something like metal could not obviously be crushed by us normally, with hydraulic press, with a bunch of syringes and fluids, for the lack of better words, you can. And yeah, now you can sort of explain how we made it.
Right. So this one I'll explain in full detail. I'll go code for code. This is how I simulated. This is not using the engineering principles that I explained, but how you can simulate your own hydraulic press and the explosion I just showed you. So what and how the explosion works on the hydraulic press is by, let me quickly go in here. Yeah. So this is the script that I used. So it's not the most efficient script. I just wrote it in a minute or two. But essentially, what I'm doing is we're checking, we're just checking depending if the hydraulic press button has been pressed or not. In a variable, we're setting it to true if it has been pressed, or if it's not been pressed. We just change that, and then we use tween service, which is essentially what allows us to move objects. So whenever the button is clicked, it changes its color using this line of code, and it tweens. That's essentially what we do. Uh, uh, so I guess even though it's not simulating Roblox physics as I would like to do it, you could theoretically use tween service to tween 3D parts, and even though it's not the most efficient way to do it, any small scale animations are very easy to do with tween service. Essentially, what you can also do is you could store the C frame values in a variable by creating a duplicate of, like, so what I've done here is create a duplicate of the hydraulic press moving parts and just tween it to that and then tween it back up. So using variables to store the C frame values or the coordinate frame values, essentially that's what I'm doing. I'll explore in this in my more of my scripting events if you're interested, but more or less this is what we have. For the explosion part, we just have a part over there, and we check when the hydraulic press reaches the bottom and just create an explosion at that specific position. So an explosion on Roblox is basically anything that you can use to explode anything. Like what else would it do? It's an explosion. So sometimes developers use explosions to simulate crashes. So initially, if you've seen one of the story of Roblox videos, it was about how developers used how two cars would crash, and we actually did a similar thing to test it in Drift Paradise, but we did and didn't end up implementing it. Essentially, what we do is use explosions to explode the cars itself. Now, while this is not something we'd achieve in real life physics, it's something that looks cool in a virtual environment. Therefore, we tried it out. So that's what explosions allow us to do. And like a simulator, like something like a bomb dropping simulator game, something like that. If you're interested in it, that's what you could use an explosion for. And you could just set the position. It's really easy to use. It's amazing because of Roblox physics rendering engine. That's pretty much it. The other one, I'll actually give you all the code in the chat if you want. There you go. You all can check it out if you want it. Also, yeah. Any questions? Please feel free to ask your questions. Thank you so much. Uh, and Mac, you want to continue?
Yeah, okay. I think you covered the hydraulic part pretty well, and I think that covers that one. Now I think we can move on to levers.
Yeah, sure. Please do.
That
Yeah.
works? Okay.
So we don't have
Now,
any
yeah.
real life Roblox demonstration for the levers, but you all can definitely check it out. You all can definitely learn the
We'll
real life explanation.
do
Yeah.
a visual. Now, levers, I'd say they're not a very cool thing like the hydraulic press, but what's really cool about them is all that you can do with it. Now, what it basically does, it lets you lift or it lets you push something. By this, I mean you apply force on one end, like the hydraulic press. Now you can exert it the other end. Now, the hydraulic machine, like we told you, lets you exert more force by applying less. The levers also do this similarly. Now, the levers were sort of the initial version of what led to the hydraulic system, but they're still very important now. And the beauty of it is it can be used to create much more complex things. Say the swings that you have, that's again levers. The seesaws are essentially the basic lever. Say even your chairs, to how wardrobes function, to even probably a lot of applications in planes itself. Now, it may not be evident at the first glance, but this is why I'd like to show it to you. Now, the main goal of engineering is to simplify things. Engineering is basically problem solving. Now, for both the hydraulic and the lever, the problem is to reduce how much strength you need to apply to do something, anything. Say it's lifting a wheelbarrow. Wheelbarrows are actually a form of lever. So, levers are designed to reduce how much power you need to push something. And they basically include something as the load, which is anything you want to add or lift. We've shown it with the use of these red blocks, these red Lego looking blocks that you have, and the white frame that you see. That's called the beam. So that's sort of the base on which everything sits. And then the main part about it is something known as the fulcrum. Now, if you can, you'll see we've shown this and made this by these two rectangular looking blocks that are sort of giving ground to the levers. This was letting it stay up. And what happens is the whole wheel, you can picture it as sort of a wheelbarrow that works around this fulcrum or these two rectangular blocks. So while you apply force on one end, force comes out the other. So, like in a seesaw, how it works is say there's two people. One person sits on one end and pushes down. What happens is the other person gets lifted up. Now, I'm sure all of you have noticed, but in case of a seesaw, what you're essentially doing, you're lifting the other person on side of it. If you've thought about it like that. Now, compare how hard it is for you to lift a person normally with your bare hands, and then how you do it easily with the help of a seesaw. Even children can do it. Children, yeah. So, what levers do, they reduce how much strength you need to do to exert some work. And now we've shown them as three types. If you'll see, if you can just go around showing them this, there's three types, and the main difference only is the position of the whole base or what is called the fulcrum. And
Right.
each of those have different purposes. So, the sort of seesaw looking one, that's if you push something down, you want to lift it up. And again, there's again a very interesting thing about it. When you're pushing something down, it's easier to push than pull. When you're pushing, you're acting with gravity. Now, gravity always pushes things downwards. So it's easier for you to push down than push something up. It's also why, if say you ever hike or you go about hills, it's always easier to come down than it is to climb up to the peaks. Similar function here, similar principle. So that's why the main goal that levers try to do, you have to push something down. When you push something down, that's how you push the other thing up. That's how wells actually sorted of work in the initial days when wells were mainly used. That used something known as a lever and then combined it with a pulley. But yeah, that's basically sort of it. And again, the most interesting thing about this is its simplicity. Now, in engineering, in technology, in coding, even on Roblox, the key thing is to make everything as simple as it can be. Say, if you're doing creating an engineering project, say you're making a drone, the main thing is to make it as simple as you can. And then, similarly, when you're coding something, to use as minimal lines of code as you can, or try to make everything simple. Another thing with this, in engineering as the fundamental, one goal is to try to make things separate from each other. Because, like we explained for the airplane, the parts are connected but they're not joined. What that does is, if there's a problem in one area, you can fix that specific area without having to change the whole thing or anything. That's similar to, I'd say, debugging code. If there's a problem in your script and that would be in a specific portion, it's easier to edit out that specific fault than if your error is in your whole code script or your whole file. Similarly, in engineering, you try to make everything separate from each other. So they work separately, but the benefit is combined. And yeah, that's pretty much it.
Okay, I think we since we're not exploring the Roblox side of this, do you just want to say any concluding thoughts before I start the Q&A?
Yeah, the concluding thoughts are basically it's important to understand and keep in mind the main principles when you're looking in terms of engineering, coding, and especially Roblox. To try to make things simple and easy for you to decode and decipher. Say, even when you're creating the different plane components, what you'll again notice is under the Explorer or workspace, everything is compartmentalized, and that again lets you identify and work on individual things, which would be opposed to as a whole object or the whole plane being compiled as one group. So yeah, that's basically it. I think we can start with the Q&A.
Yeah. Okay. Alrighty, everyone. So, this is pretty much towards the conclusion of the event. We'll take next 5-10 minutes for Q&A. Anyone has any questions, please bring them forward. We do have a few Russian viewers over here. If you want to ask them any Russian, uh, please ask any more questions. I just send that in the chat. I doubt people are asking the questions as I expected. I didn't think that. Uh, mm, Anyone has any questions, please bring them on. We'd be happy to answer them.
Uh,
I doubt we have our English viewers asking questions. They're online, as I can see, but I don't believe that asking questions. Please. So I guess I'll just answer some Roblox related questions about myself, and I'll ask you. I guess we can interchange questions. Uh, it,
yeah, okay.
yeah, okay. Please. Okay. So I'll ask a question for you. What got you interested in engineering?
Okay. For me, engineering is really problem solving. Or I'd say, and this is very cliche, but for me, engineering is an art of turning a vision or a goal into reality. So, like in the case of the planes and the helicopters and all we had, we turned the goal of flying into reality, so into the reality of the real components. And yeah, the
You have a
basic
question? Mhm.
ability to problem solve is what drew me in. Okay, you have a question. How accurate is Roblox gravity to real world gravity when
Okay,
calculating physics?
I'll answer that. Okay. So,
Okay.
as far as I know, the Roblox uses gravity units. I am not fully aware of this one, but as far as I know, we have 1.9. So one star converts about 5 centimeters. As far as I know, I read it in a blog post back in the day. And because we have a 1.96.2 gravity value in starts, I think starts per second squared, which I'd say the default unit will be. So it just uses a start version of like real world gravity, I'd assume, because we see that we have like our jumping animations, for example, are very consistent with real life. So what I'll do is I'll actually jump in real life right now. Uh, uh, so where we like it just takes like about a half a second, or sometimes like I'm just estimating in my head, where we have like I just jump in and I land down. So I assume it's like very real. It's done in a way to tune it to a realistic fashion where developers can choose what they want to. I'd assume that's the case. But you want to explore how real gravity works, Matt? Matt, you there? I think he's
Sorry.
yeah, okay.
Am I there now?
Could you
Okay.
explain how real world gravity works? Quickly, or add something. So I guess we
Okay.
have this start versions of this where we can set our, even though because we can set our own gravity, it might not always be realistic. But I'd assume 1.196.2 is just a centimeter based conversion because one start converts to about 5 centimeters or 0.05 meters. So just quickly, okay,
Yeah.
I'll answer this question. How do we
Okay.
create a spaceship using Roblox Studio? So it actually would. So what I would do honestly is I just like how we have the open source plane kit, right? So this is developed by a developer back in 2016, but it works flawlessly even to this day. So what you could do is build your own plane body and just use the instructions on that, and just like you're technically building a plane, but you could use that as a spaceship if that makes sense. There's something called the open source plane kit. You can search it on the developer forum if I'm correct. Yeah, but that's what I do. Anyway, you want to cover real world gravity real quick?
Yeah. So real world gravity again, I'd say it is possible to simulate it. It is done because that is what lets your cars move. Again, in all your games, that's what lets you walk. So the principle of gravity is present, but how accurate it is, that depends if you are yourself are a developer. That depends on the criteria you set in, because you can picture Roblox or any platform or anything like that as sort of a simulation. Now, the accuracy of the simulation depends on what you input as the code. So, like when we were making the plane, we decided how fast it could go, and we decided the speed at which it would need to take off and land. Now, similarly, you can change the value of gravity or how easy or hard you want for movements to be. Now, although this gives you a chance to change gravity and try to model it, again, remember that it won't be perfect. Because for it to be perfect, you need to consider every single factor. Say your character itself, how much your character would weigh. Say cars, you'd have to define weight for every single component, and then you'd have to add the gravity value. So while it helps, while the gravity principle is there and it does help you understand and run some calculations, there will be error based on the system itself. So this would be something known as systematic error, where say you're doing a research project on Roblox. One of my friends did a similar gravity one on Minecraft actually. So while the whole system would have a constant gravity, there would be something known as systematic error, meaning all your data would be off by a bit. Now, by a bit, I mean I would round around a 20 to 30% margin, but it is helpful for running calculations and coming up to objectives because the principle of gravity is there. It's just not as accurate as real life.
Okay,
So, yeah.
we have three more questions. So we'll get started with this one. Real quick.
Okay.
Will there be a public repository for some code to test out? Unfortunately, these are just free models. You can look it up in the toolbox. It's like plane, helicopter. But for my introduction to scripting events, we for the upcoming ones at least, we'll have a public repository of all the code. I'll publish it as a resource in the dev forum, or I'll publish it as a resource in the description. There will definitely be a full repository of all the code I use in my upcoming events for sure. Uh, Another question. Are there any substantial differences between this physics engine and other games and engines? I don't have an experience in UE or Unity, so I can't really say. As for Roblox's physics engine, you can either do your own thing or do what like you could I remember you can even make something like a car without any scripts. Like I remember you could just like place a vehicle seat on something, and you can use your welds and all that just to make a car directly without any. There's something called a vehicle seat which allows you to maneuver, and it's already pre-built in. So anyone with even very little experience, this is what I like about Roblox. Any super advanced people like myself, or people who are just getting started, can do whatever they want, and I think that's kind of cool. Uh, the other question, this is for Mech. Would a hydraulic press be able to crush another hydraulic press?
Okay.
That's an interesting
Creative
one.
question.
That's an
Yeah,
interesting one.
interesting. Well, I guess yeah, a hydraulic press can technically crush anything. Just the hydraulic press that does the crushing needs to be bigger, so it actually fits. But yeah, technically, yes, it can.
Yeah, okay. Also, as per Hal's question about Roblox gravity, we also have a more. So, if we set the density to 1, which is mass upon volume, Roblox 8,000 Roblox units of mass converts to about roughly 1 kilogram. So I guess you could calculate manually about like with your 9.8 meter per second square newton. So you theoretically convert it all and use real. You could simulate like life gravity in Roblox for sure. Set your gravity in workspace to 196.2 and you could very realistically simulate gravity in Roblox, which I find really cool at the same time. But there might not be some factors like air resistance. You'll have to count for that. Maybe have a constant, maybe have a variable air resistance. There's a lot of stuff you can do, and I find that kind of cool. Uh,
Yeah.
we do have someone asking questions in Russian. I might translate that. Mac, do you have a question for me?
No, I think that's good. We
Hey, I
just
asked you a
get
question. You
these
should ask me
other
a question.
questions. Okay, sure. I'll ask you a question.
Okay, there's one thing.
Uh,
One question
okay.
though. We have a Russian question.
Yeah.
What do you mean by
What's that?
co-prime pairs? So co-prime pairs are basically pairs of co-primes, I guess, where there's like two different prime numbers, and I guess co-primes are just like 13 and 17 are co-primes, I guess 17 and 19, I think, are co-primes. So like
They
11,
don't
13.
have common factors.
Yeah, they don't have common
So,
factors.
yeah.
That's just prime numbers. Yeah, I'd assume that. Anyway, what's your question, buddy?
Okay. Okay, I'll ask you one thing. What sort of got you into Roblox and what kept you connected with it? Because I know Roblox is again a very unique thing, and the level of experience that you've gotten, all the work you've gotten to do, that's completely thrilling. At the same time, hard to believe that you've come this far in this short amount of time. So,
It's
what
been
got
five
you
years,
to the
buddy.
stage?
It's been a while.
Yeah.
Yeah, anyway.
So, my question is, what kept you hooked?
Okay, so I guess you know how there's like something I call this like the oversaturation effect. That's what I call it. Uh, so what I'll say is uh what kept me hooked was first of all through the video game like experience side of things. Like with the variety of different experiences you have, even as a like a player, you could just like you could go from Jailbreak to maybe like something like Mad City. Like there's a similar genre of games, completely different games. So like you have like very different view. Sorry, my bad experiences. You have two different complete genres of experiences where you could go from one thing to another, and you whatever you find interesting keeps you hooked. I guess that's what makes my thing to Roblox quite good. Also, being able to be financially rather close to independent, rather, and having something that you know, like, uh, yeah. So basically, having something that like helps you financially while being enjoyable to do, I guess just kept me in there. And as learning about it today, like I couldn't fully answer some of the questions that were asked, and I'd love to be able to learn more, go back, do my research, and learn more. I guess the love of learning kept me hooked. That's pretty much it.
Right. Yeah, that makes sense. Definitely agree with you.
Okay, we
Right.
do have
Finding
one more
your true
question from
passion.
Skelly.
Okay.
Uh, will you be able to replicate the gravitational pull of a planet accurately? How do you calculate the speed or mass of the pull?
Okay.
So
I
you
have an
can
answer.
you can do the calculation part. I'll explain the replicate part in a bit. Sure.
Well, there are already simulations that have been made, they've been developed, that sort of take in the values of planets. By values, I mean the value of gravity and the distance. And through that, you can calculate the pull, mass and distances. But again, that's not completely correct. It's an estimation. You can't really take a planet and put it on a weighing scale or something. So, yeah.
I mean, if the planet is like the size of a ball, I mean, you never know what the future holds for us, right? Anyway, that was a joke. Don't worry.
Yeah.
Okay, so
Yeah.
if you want to replicate in Roblox, I have a weird. I just came up with this on the fly. So what you could do is like have a part like this, right? Like which is like super close to the ground. Put something in the air, right? Unanchor that. And check when the part hits this spot, right? So use workspace or touches around, like call that specific name. So what I'll actually do is, yeah,
Weird
stretch.
situation, but
Yeah, I think at least we go the second.
it's
Yeah,
good. And I'll send the link of the Mechatricon YouTube channel. So
yeah.
if you want to learn more about similar topics, you can go through the YouTube. But that's
Giving us the wrong value then. So much for tuning in today. We'll see you all in my next event if that's cool. Uh,
pretty much it. Yeah.
yeah. Goodbye, everyone. See you.
Bye.
Hey,
Thank you so
thank you,
much.
Jordan. Bye. Thank you all so much for
Yeah.
attending. Thank you.
Bye.
Bye. Bye.